Determine the complex exponential Fourier series for a periodic rectangular pulses shown in figure. Determine the complex exponential Fourier series for periodic rectangular pulse shown in figure. And plot its magnitude response. This is the waveform. X of t minus tau by 2 to plus tau by 2. This is the t-axis. Here minus t0 by 2 plus t0 by 2. T0 minus T0. The amplitude is A. First of all, find out the time period of the waveform. Here the starting point is here. The starting point is here like that. Here ending point is here. After that, from T0 by 2, again the waveform is repeated. This is the one way to represent the time period of the waveform. Or else, from this point, this is the minus tau by 2, T0 by 2, and T0. This is the another way of representing the time period. I will consider this one. This is the T0. This is the T0 plus T time period. Time period of the waveform. This is the time period of the waveform. This one time period of the waveform. T0 is equal to minus T0 by 2. T0 plus capital T is equal to T0 by 2. Therefore, substitute T0 here minus T0 by 2 plus T is equal to T0 by 2. Therefore, time period T is equal to T0 by 2 plus T0 by 2. That is T0. Time period of the waveform is T0. Here, find out the complex exponential Fourier series. According to complex exponential Fourier series, the formula is x of t is equal to sigma n is equal to minus infinity plus infinity Cn e power j n omega naught t, where Cn is equal to 1 by t. Here small t0 plus capital T x of t e power minus j n omega naught t dt. Here t is the time period of the waveform. T is equal to T0. Here small t0 is minus T0 by 2. Small t0 plus capital T is T0 by 2. This is the limits I have to consider. Here 1 by t is equal to T0. 1 by T0, small t0 is minus T capital T0 by 2 to plus capital T0 by 2 x of t e power minus j n omega naught t dt. Here, this minus t naught by 2 to t naught by 2, some sub intervals are there. Sub intervals. Minus t naught by 2 to minus tau by 2, the value is 0. Minus tau by 2 to plus tau by 2, the value is a. Plus tau by 2 to t naught by 2, the value is 0. Minus t naught by 2 to plus t naught by 2 interval is divided into 3 intervals. 1 minus t naught by 2 to minus tau by 2. This is one interval. Minus tau by 2 to plus tau by 2. The value is a, another interval. Plus tau by 2 to t naught by 2. The value is 0. Based on that, I have to divide this interval into 3 intervals. That is equal to 1 by t naught minus t naught by 2 to minus tau by 2. The value of x of t is 0, 0 to t dt, plus minus tau by 2 to plus tau by 2. The value of that interval, the value of x of t is minus tau by 2 to plus tau by 2. The value of x of t is a. Here a into e power minus j n omega naught t dt plus tau by 2 to plus capital T naught by 2. Again, the value is 0 from that periodic function. Here finally 1 by t naught. These two are zeros. Minus tau by 2 to plus tau by 2 a e power minus j n omega naught t dt. Integrate this one. Here a is bring outside a by t naught. Integral of e power minus j n omega naught t is e power minus j n omega naught t. Here integrate by jn minus jn omega naught. So our interval is tau by 2 to minus tau by 2. E power x integral is e power x limit. E power 2x integral is e power 2x by 2, like that. Here t quotient is minus j and omega naught. This is the denominator term. Minus sign is very, very important. Substitute a by t naught. This is the cn value, a by t naught. E power minus j n omega naught. Here t value is tau by 2 minus e power minus j n omega naught. Here t value is minus tau by 2 by minus j n omega naught. That is equal to a by t naught. Here minus sign is minus into minus into minus plus. Bring this one into this side. This term minus into minus plus j n omega naught tau by 2 minus e power minus j n omega naught tau by 2 by j n is bring out omega naught is equal to 2 pi by t naught. Omega naught is equal to 2 pi by t naught. A by t naught n. Here pi by t naught. E power j n omega naught tau by 2 minus e power minus j n omega naught tau by 2 by 2 j. T naught cancel. Therefore, a by n pi e power x jx minus e power minus jx by 2j is sin x sin n omega naught tau by 2 n omega naught tau by 2. Here a by n pi sin n omega naught is 2 pi by t naught into tau by 2 tau by 2 2 to cancel. Here finally Cn value is a by n pi sin n pi tau pi t naught. This is the tau pi t naught is the duty cycle of the waveform. Suppose tau pi t naught is the duty cycle of the waveform. Duty cycle of the waveform. The duty cycle is 50%. 50% means 1 by 2. Tau by t naught is equal to 1 by 2. Therefore, Cn is equal to a by n pi sin n pi into tau by t naught is 1 by 2. N pi by 2. The magnitude of Cn is mod Cn is equal to a by n pi sin n pi by 2. We know that sinc function sin pi x by pi x is sin sinc x. See the sinc function. Here mod Cn is equal to a by n pi sin n pi by 2. Here n pi is there, by 2 is not there. Here n pi by 2, here multiply to numerator and denominator, that is equal to a by 2 sin n pi by 2 by n pi by 2. Sin n pi by 2 by n pi by 2 is a by 2. Sin n pi by 2 by n pi by 2 is sin n by 2. That is sin n by 2. This is the sinc function. Here the sin n by 2 pi sin pi n by 2. This is the a by 2 n by 2. Finally, mod Cn is equal to, consider mod Cn is equal to, let a is equal to 1. Let a is equal to 1. Consider this function 1 by 2 sin n pi by 2 by n pi by 2. Sin n pi by 2 by n pi by 2. Let n is equal to 0. Let n is equal to 0. If we want to draw the magnitude response, mod C naught is equal to 1 by 2 sin 0 by 0. 1 by 2 0 by 0. Sin 0 is 0. Indeterminate value. We go for L'Hospital rule. L'Hospital rule means sin 0 is equal to differentiate this above equation with respect to n sin n pi by 2 by differentiation of dn with respect to n pi by 2. That is equal 1 by 2 sin differentiation n pi by 2 is cos n pi by 2. Differentiation of n pi by 2 is pi by 2. Here differentiation of n pi by 2 is pi by 2. Pi by 2 is cancelled. Substitute n is equal to 0. Therefore, C value 1 by 2 cos 0 that is 1 by 2. 1 by 2. Coming to let n is equal to 1. Let n is equal to 1. Therefore, mod C1 is equal to substitute n is equal to 1 in that expression. 1 by 2. That is equal to 1 by 2 sine pi by 2. N is equal to 1 sine pi by 2. Sine pi by 2 by pi by 2. Sine pi by 2 by pi by 2. N is equal to 1 sine pi by 2 by pi by 2 into 1 by 2. 1 by 2, 1 by 2 cancel. Therefore, the value sine pi by 2 is 1, pi is 3.14 here. 2 cancel. The value is 0.318. Here pi is equal to outside that sine function pi value is 3.14. Inside that pi is 180. 180 by 2. 180 by 2, that is 90. Sine 90 is 1. 1 by 3.14 is 0.318. Let n is equal to 2. Let n is equal to 2. C2 is equal to 1 by 2 sine 2 pi by 2 pi 2 pi by 2 pi n pi by 2. Here 2 is substituted here. 2 into pi by 2. 2 to cancel. That is equal to 2 to cancel. Sine 180 degrees is 0. Therefore, for n is equal to 2, the value is 0. Let n is equal to 3. Let n is equal to 3. C3 is equal to 1 by 2 sine 3 pi by 2 pi 3 pi by 2. This value is minus 0.1. Minus 0.1. Let n is equal to 4. Let n is equal to 4. C4 is equal to 1 by 2 sine 4 pi by 2 pi 4 pi by 2. That is equal to sine 2 pi is 0. Let n is equal to 5. Let n is equal to 5. Mod C5 is equal to 1 by 2 into sine 5 pi by 2 5 pi by 2. Sine 5 pi by 2 into 5 by 2. That value is 0.06. Outside that sine function, the pi value is 3.14. These are the values. N value. Mod Cn value is 1 by 2 sine n pi by 2 by n pi by 2. N is equal to 0, 1, 2, 3, 4, 5. For n is equal to 0, the value is for n is equal to 0, the value is 1 by 2. 1 by 2 is 1 by 2, that is equal to 0.5. For n is equal to 1, the value is 0.318. For n is equal to 2, the value is 0. For n is equal to 3, the value is minus 0.1. N is equal to 4, 0. N is equal to 5, 0.06. In similar fashion, negative value for n is equal to 0, minus 1, minus 2, minus 3, minus 4, minus 5. Mod Cn value is say 0.5, 0.318, 0, minus 0.1, 0, 0.06. Draw this one by using these values. Draw the magnitude response Cn is equal to n. For n is equal to 0, the value is 0.2. For n is equal to 1, the value, this is the 1, the value is 3. The value is 0.318. 1 by 2 is 0.5. 1 by 2 is 0.5. 0.3 is somewhere here. For n is equal to 2, the value is 0. This is the sinc function. For n is equal to 3, for n is equal to 3, the value is minus 0.1. Here minus sign is here minus 0.1. N is equal to 3. For n is equal to 4, the value is 0. For n is equal to 5, here 0.06 is there. For n is equal to 5, 0.06. For n is equal to 0, like that. In the similar fashion, in the negative side, this is the sinc function. In the negative side, this is minus 1, minus 2, minus 3, there's some value, minus 4, minus 5, minus 6. This is the magnitude plot of the rectangular function. Finally, x of t is equal to sigma n is equal to minus infinity to plus infinity Cn e power j n omega naught. We know that Cn value is n is equal to minus infinity to plus infinity. Cn value is a by n pi sin n pi by 2 sin n pi by 2 e power j n. This is the exponential Fourier series of the waveform. In this video, the explanation is completed.